Hello, time for another episode, maybe a rambling. The dark matter mystery deepens with the demise of a reported detection. A new experiment fails to support previous report of WIMPs in space. In mystery stories, the chief suspect almost always gets exonerated before the end of the book, typically because a key piece of evidence turns out to be wrong. In science, key evidence is supposed to be right, but sometimes it's not. In the mystery of the invisible dark matter in space, evidence implicating one chief suspect has now been directly debunked. WIMPs, a Titan particle widely regarded as prime dark matter candidates, have failed to appear in experiments designed specifically to test the lone previous study claiming to detect them. For decades, physicists have realized that most of the universe's matter is nothing like earthly matter, which is made mostly from protons and neutrons. Gravitational influences on visible matter, stars and galaxies, indicate that some dark stuff or unknown identity pervades the cosmos. Ordinary matter accounts for less than 20% of the cosmic matter abundance. For unrelated reasons, theorists have also long suggested that nature possesses mysterious types of tiny particles predicted by a theoretical mathematical framework known as supersymmetry, or SUSY for short. The particles will be massive by subatomic standards, but will interact only weakly with other matter, and so are known as weakly interacting massive particles, hence WIMPs. One of the main possible species of WIMP, one presumably the latest one, should have the properties necessary to explain the dark matter messing with the motions of stars and galaxies. Way back in the last century, searches began for WIMPs in an effort to demonstrate their existence and identify which species made up the dark matter. One research team announced apparent success, an experiment called DAMA for dark matter, get it? Consisting of particle detector buried underneath the Italian Alps. Seemingly did detect particles with properties matching some physicists' expectations for a dark matter signal. It is a tricky experiment to perform, relying on the premise that space is full of swarms of WIMPs. A detector containing chunks of sodium iodide should give a flash of light when hit by WIMP, but other particles from natural radioactive substances would also produce flashes of light even if WIMPs are a myth. So the experimenters adopted a clever suggestion proposed earlier by physicists Catherine Fries, David Spergel, and Andrzej Drucker, known formally as annual modulation test. Let's just call it the June-December approach. As the Earth orbits the Sun also moves, traveling around the Milky Way galaxy, carried by a spiral arm in the direction of the constellation Cygnus. The galaxy really is full of WIMPs. The Sun should be constantly plowing through them, generating a WIMP wind. It's like the wind you feel if you stick your head out the window from a moving car. In June, the Earth's orbit moves in the same direction as the Sun's motion around the galaxy into the wind. But in December, the Earth moves the opposite direction, away from the wind. So more WIMPs should be striking the Earth in June than in December. It's just like the way your car windshield smashes into more raindrops when driving forward than going in reverse. As you can see from the illustration. An astrophysics conference in Paris in December 1998, Pierluigi Belli of the DAMA team reported a clear signal, or at least a strong hint, that more particles arrived in June than December. But precisely, results showed an annual modulation and frequency of light flashes, peaking around June with the minimum in December. The DAMA data indicated a WIMP waning at 59 billion electric volts, roughly 60 times the mass of a proton, but some experts have concerns about the DAMA team's data analysis, and other searches for WIMPs. With different detectives and strategies, should have WIMPs if Dama was right, but still didn't. Still, Dama persisted. Advanced version of the experiment, Dama Libra, continued to find a June-December disparity. Perhaps Dama was more sensitive to WIMPs than other experiments. After all, other searches did not duplicate Dama's methods. Some used substances other than sodium iodide as detecting material or watched for slight temperature increases as a sign of WIMP collision rather than flashes of light. For that matter, WIMPs might not be what theorists originally thought. Dama initially reported 60 proton mass WIMPs based on the belief that WIMP collided with iodine atoms, but later data suggests that perhaps the WIMPs were hitting sodium atoms, implying a much lighter WIMP mass. Lighter than other experiments have been optimally designed to detect another possibility. Maybe trace amounts of the metallic element thallium, much heavier atoms than either iodine or sodium, has been the WIMP targets. But recent review of that proposal found once again that Dama results could not be reconciled with the absence of a single other experiments, and now Dama's hope for vindication has been further dashed by a new underground experiment, this one in Spain. Scientists with the ANAS collaboration have repeated the June-December method with sodium iodide in an effort to reproduce Dama's results. With the same method and materials, after 3 years of operations, the ANAS team reports no sign of WIMPs. To be fair, the no WIMP conclusion relied on a lot of seriously sophisticated technical analysis. It's not just a matter of counting light flashes. You have to collect rigorous data on the behavior of 9 different sodium iodide modules. You have to correct for the presence of rare radioactive isotopes generated by cosmic ray collisions while the modules were still under construction. The statistical analysis needed to discern a winter-summer signal difference is not something you should try at home, unless you're fully versed in things like the least square parallelogram or the Loam-Scraggle technique. Plus, ANAS is still going, with plans to collect 2 more years of data before issuing a final analysis. So the judgment on Dama's WIMPs is necessarily final. Nonetheless, it doesn't look good for WIMPs, at least for the WIMP motivated by belief in supersymmetry. Sadly for supersymmetry fans, searches for WIMPs from space are not the only bad news. Attempts to produce WIMPs in particle accelerators also so far failed. Dark matter might just turn out to be some other kind of subatomic particle. If so, it would be a plot twist worthy of Agatha Christie, kind of like the period turned out to be the killer. But symmetry had long been physicists' most reliable friend, getting many great successes, from Einstein's relative theory to the standard model of particles and forces. Still, a failure to find the supersymmetry particles so far does not necessarily mean they don't exist. Supersymmetry just might not be as simple as it first seemed, and so supersymmetry particles might just be hard to detect than scientists originally surmised. But supersymmetry does turn out to not be so super. Scientists might need to reflect on the ways that faith and symmetry can lead them astray. Now tell me what you think in the comment section. And that's it from another episode of Maybe I'm Rambling.